positive. This next section is on writing the equation of a quadratic. Remember, the equation of a quadratic looks something like this or this. And which one you choose depends on what information you're given. When you're writing an equation, you don't need to draw the graph. All you need to do is be able to write one of these equations. So let's talk about it. If you have been given the vertex, and it will tell you, or you might be able to have to read it off the graph. The vertex, remember, is the turning point. So if it's a graph that looks like that, it's going to be that bottom point right there. It's a turning point of the graph. Okay? And we call the coordinates of that point, you know how we normally call the coordinates of a point x and y. In this case, we call it h and k. So for example, if you had the point 2, 3, h would equal 2 and k would equal 3. If you had the point -8, -7, h would equal -8, k would equal -7. So let's do an example of writing an equation once we have actually been given the vertex. Our example is this one right here. The vertex we have been given is -5, 2. If you want to be able to do this, write what h and k is. H is equal to -5, k is equal to 2. Now remember, the general equation, if we have a vertex, is this form. So all we do is write that out. We write y equals x minus h. Now what's h? H is -5. So we write -5 squared. And then up here, so we put our -5 squared, and then we go plus k. So we'll go plus 2. Now you could simplify that to be y equals x plus 5 all squared plus 2 if you want to, but that's completely correct, that other line. Do you want another example? Let's do another one over here. Y equals x take 21 all squared. Let's go plus 21 and go take 8. Remember, we're comparing it to the graph y. Oh, actually, I want to give you the vertex. I don't want to tell you what the equation is. Let's give you the vertex, and I'm going to give you the vertex -21, -8. Remember, we're going to try and write it in this format. X take 8 all squared plus k. This is the vertex we've been given. So let's say what h and k are. That's h, that's k. H equals -21, k equals -8. So we just go y equals x minus h, -21, all squared, plus k. K is -8 plus -8. So y equals x minus minus is a plus, 12 all squared. If we have a plus and take together, that makes it a minus 8. So you can, if k is -8, this number will be -8. If k is +8, this number will be +8. But you just have to be a bit careful with this one in here. It's a little bit trickier, but that's all it is. Alright, that's that form. What about if we've been given, instead of being given the vertex, we get given the x-intercepts? Remember the x-intercepts, if you've got a graph that looks like this, the x-intercepts are where that graph cuts the x-axis. Makes sense, doesn't it? Where a graph cuts or touches. So the general form in that case is y equals x take a times x take b. Alright, that's the general form of that graph. So if we've got our x-intercepts down here, and then -5 and 3, we'll call one of them a, we'll call one of them b. And then we put them into the formula. We go y equals x minus a. That's going to be x minus -5 times x minus b, x minus 3. So then, because minus minus is a plus, we get that as our result. Let's do another one. I'm going to give you two x-intercepts, or in fact, I'm actually going to get you to read them off the graph. So I've got that point there and that point there. I haven't told you what the x-intercepts are, but you can read as well as I can that the x-intercepts are actually 2, and 5. Now I'm going to call one of them A, I'm going to call the other B. Alright? So my x-intercepts are going to be, my equation is going to be y equals x take A, which is take 2, times x take B, x take 5. And that's the answer. So, to summarise, if you've got a vertex, you call the coordinates of the vertex h and k, and you put that into this formula. If you've got the intercepts over here, you've got the x-intercepts, you call them A and B, and you put them into that formula. Hope that helps.